So hopefully we're going to cover order of operations, analyzing data, adding, subtracting, multiplying, and dividing rational numbers. So order of operations. You'll often see this word PEMDAS. Sometimes they say, please excuse my dear Aunt Sally, but ultimately what it stands for is parentheses, exponents, multiply and divide, and add and subtract. And this is the order you're supposed to do stuff in when you're simplifying. So this isn't the order you do equations in. Eventually you'll get to the point where it'll have like x equal to numbers. This is the order you do simplification in. If you have a lot going on to simplify, then we need to follow this order. And multiply and divide isn't necessarily you must do all multiply first, then all divide. It's go in order from left to right. If all you have left is multiply and divide, go left to right. And if all you have left for add and subtract, you go left to right. So on this particular problem, we do have parentheses. The parentheses is doing what's inside. So inside of these parentheses, you kind of have to start order of operations again. So inside the parentheses, we look for any other parentheses. Sometimes we'll have two sets. We don't have any, so we skip to exponents. We don't have any exponents, so we skip to multiply and divide. So I see divide and multiply all in order, so we just need to follow left to right. Even though divide comes before multiply, we just go left to right. So we do the 8 divided by 2, which is 4. Once we get that answer, we take that answer and multiply it now by 3. 4 times 3 is 12. Everything else we just funnel down. We haven't done anything with the 3. We haven't done anything with the 2. We keep everything else just as it is for now. So we're still on these parentheses. We've got to keep going till we get down to one number. And 12 plus 1 is 13. So now, at this point, we don't have to worry about the parentheses anymore. When we're trying to simplify what's inside, it falls under the parenthesis category. Now this is really just multiplication. We've done everything we can inside. Eventually we'll need to use multiplication with anything outside. So now we go back to the beginning. We're done with our parentheses. We look for any exponents. So we do have an exponent. Exponents don't mean to multiply by each other. Maybe I should have chosen a different exponent. It means multiply 2 by itself 2 times. If this had been 2 to the third, we wouldn't do 2 times 3, we'd do 2 times 2 times 2. Multiplied together 3 times. So 2 times 2 is 4. 3 minus 4 times the 13. We've done our exponents. Now there's no more exponents at all in the problem. And we do not minus first. We like to read left to right. That's how we read English. That's how we work. This is not the same. We must do the 4 times 13 first. Multiply comes before subtract. So we must do this 4 times 13, which is 52. And feel free to use a calculator. I did this in a calculator earlier. If you don't have a calculator, I just look for Google Calculator or your computer calculator. Calculators are great, super helpful. Use them. So, and then we just do our subtraction. 3 minus 52. It's really a positive and a negative, so when there are two different signs, you subtract the numbers. 52 minus 3 is 49. but we keep the sign of the bigger number that was negative. And again, if you don't want to think about that, plug it into a calculator. Negative 49. Once you get down to one final number, that is your final answer. So, we've worked through an entire problem. I want to take a second to see if you guys have any questions so far. You can just type into the chat if you have a question. I'll give it like 15 seconds. If you don't have a question, we'll just move on to the next problem. Okay, so don't see any questions so far. Again, anytime you have a question, go ahead and type it in. I have to look back and forth, so if I don't notice it for a minute, just please bear with me. So this is still order of operations, but sometimes they give you an expression with variables in it. These letters are called variables. You can use any letter. They often stick with ones that don't look like numbers though. They don't use like S's a lot because they look like 5s, but they really can use any letter possible. And when they give you numbers that stand for the letters, we just plug them in. So we have to rewrite this problem before we can do any of order of operations and replace the letters with their corresponding numbers. It said A is 3, so we replace it with a 3. It said B is 1, so we replace it with a 1. And I'm actually going to change this slightly. Something that kind of can be difficult is if you ever have a negative. So if we replace B with negative 1, there's really two minus signs going on. There's minus from the question itself, but then there's also a minus sign from the number you plugged in. So you have minus minus. And sometimes when they write it out in the program, they might add an extra set of parentheses there. Anytime you have a negative number, sometimes they put it in parentheses. That doesn't necessarily mean now it's multiply, it's just to separate it and say this is a negative number, but you don't have to include those parentheses. So now we're going to follow order of operations. So we go parentheses first. So we have two sets this time. We have the outer brackets. These are still considered parentheses. We have the inner parentheses, which are parentheses. And you always work your way inside out. Inside set first, if there's ever more than one. So on this one, we need to then order of operations again. We say, okay, we do have an exponent. Exponents come first. 3 squared is 3 times 3. Or if you want to plug it into a calculator, 3 squared, it can depend on the type of calculator. This one, there's this XY button. The Google Calc, when you actually click it, it actually puts it in the exponent spot. It'll put it above for you. Some calculators will have a button that looks like this. It's called the caret key. 3 caret key 2 will also use an exponent for you. There are so many different calculators. If you have one specifically, feel free to send me a picture of the calculator and I can walk you through how to do it on that specific calculator. So we do the 3 times 3 first. That was the exponent. And then we have 9 minus negative 1. When you have a minus directly next to a minus, that is the same as adding. You can, again, use a calculator. You can also think of it as the number line. Sometimes I draw out my number line when I'm adding and subtracting, especially positives and negatives. Sometimes it's good to visualize it. So 9 minus negative 1 is saying start at your positive 9. And then normally minus tells you to go left, but the negative then switches it to the opposite direction. So minus minus actually tells you to go right. So you're up to 10. 7 plus 3, now we have 10 inside here. And again, once you get down to one number inside the parentheses, you don't have to worry about that set anymore. This is now just multiply, 3 times 10. Calculator-wise, if you are going to plug it in, 9 minus -1, Google Calc does not. A lot of calculators have a separate negative button. Google Calc, I think you have to put a parenthesis then to do 9 minus -1 in this kind of calculator. Most of them have a separate negative versus minus button. And let me scroll down a bit so we can keep going. So now we look at the brackets as its own set, and we do order of operations for the brackets. We have no exponents. We're doing the brackets, so that covers the parentheses. And we move on to multiply. We do have multiply, so we do the 3 times 10. We have no divide. We do have add. So we do the 7 plus 30, which is 37, and then 2 times 37 is 74. So again, number next to a bracket, that's multiply at this point. Because once we get it down to one number, we don't have to worry about the parentheses step anymore. So that's all for the order of operations. That covers most of what you will see for that section. Again, I just want to double check, is there any questions on this topic before we go to the next? Not seeing anything come up. Oh, wait. Okay, perfect. Definitely let me know if I go too fast. I'm happy to pause. Just send me another chat message when you are ready for me to move forward. I think I'll probably pause recording so there's not a long break. So one of the other things requested, the person's not here, but we can still cover it because it's one of the sections. This is from the Analyzing Data section. They asked how to find the mean, median, and mode. And I should have spell checked before doing this. Median. So mean, median, and mode, they're different ways to kind of analyze a whole set of numbers. Mean, you probably have heard as finding the average. So the mean, you're adding all the numbers together and dividing by how many there are. If there's 5 numbers, divide by 5. If there's 8 numbers, divide by 8. Median just means the middle number. We will just put them in order and search for the middle number. And the mode is just the number that occurs most often. And something from this section that I think I probably should have included was range. They may ask about the range, and it's just the highest number on the list minus the lowest. It's just trying to figure out what's the difference, what's the spread. So finding the mean, median, mode, I put an example problem. And they can often ask what measure of central tendency best describes the data. Measure of central tendency is just the fancy math term for mean, median, or mode. It's just kind of how to say in general, could be mean, could be median, could be mode. And usually the way to tell is mean is not good if you have an outlier. If you have one number that just doesn't fit in the group at all, then mean is not the best option. If they're all about the same range, then mean is a good measure of central tendency. So the data, time spent on the internet in minutes per day. So someone asked a bunch of friends, how much time do you spend on the internet per day? And some said 75 minutes, 38 minutes. Someone collected all this data. And now they want to analyze it. So to analyze this data for the mean, add them all together. 75 plus 38 plus 43 plus 120 plus 65 plus 48 plus 52. And then once you get that, we're going to have to divide by how many there are. So we have 1, 2, 3, 4, 5, 6, 7. So we will end up dividing by 7. Yes, so outlier, this one has an outlier. Which of these numbers just don't fit in? Which one's just kind of far away from all the rest of the numbers? This set of data does have an outlier. So what do you guys think? Which number doesn't fit? Good, 120. Everything else is, 40s, 50s, 60s. 120 is just way far from the rest. So we actually can answer this, which measure of tendency best describes the data? Not the mean. We know for sure right now, not the mean. So we add all these together. I recommend just plugging it into a calculator. That's a lot to do by hand. I have already plugged it all in, and it's 441. So then we do the division. 441 divided by 7 is 63. So the mean or average of this data is 63. And like your grade in a class is calculated usually finding the mean. What you get on each assignment, add it all together, divided by how many assignments there are. Like this is used a lot calculating grades. The median is the middle number, but for the middle number you must put the data in order. So we just go lowest to highest. When I'm doing this, I like to have it written out and cross out as I go. Sometimes you get a lot of numbers, it's hard to keep track of. So you just cross out as you go so you know what you've already written down. And we're looking for the number in the middle. I also usually just cross out. I say, okay, I'm going to cross the first out and the last out. I just do both sides and work my way from the outside in until I'm left with hopefully one number. It is possible you might be left with two numbers. Right now we are left with just 52. So the median is 52. If we had had one additional number, say we had 125, you end up having two numbers left in the middle. Oops, that was not what I wanted to do. Let me try this again. So if you're left with two numbers, because when you cross out, you end up with two things in the middle, you actually have to average those two things. You would have to do 52 plus 65 divided by 2 because there's only two of them. So that's if. That's not for this data, but if it were to happen, you want to watch out for that. So then mode is just most often. So on our list of numbers, were there any numbers that got repeated? Did we see any number twice or three times? So if you look at the list, nope, there were no repeated numbers. So it's possible to have no mode, none. Mode, it has to occur more than once. So if we added to our list, let's say we added another 43, maybe even another 38, it's also possible to have two modes. 43 happened twice, 38 happened twice. If we added those to our list of numbers, now our mode is 38 and 43. So mode is rarely the best way to describe data. For this one, the best way to describe the data is the median, the middle number. So any additional questions on mean, median, or mode? Oh, I guess I did talk about range. Range for this data is just the biggest number, so the 120 minus the lowest number. So I was thinking about the lowest number being 38. So 120 minus the 38 gives us the range, 90, 82. Okay. So now, any other questions on mean, median, or mode? What is the 441 divided over 7 for? So, when you are calculating the mean, this was all our work for the mean. The mean is adding up all the data we were given. I'm going to erase our extra numbers so we don't get those as part of this. 75 plus 38 plus 43, we just added all the numbers together. But you have to divide it by how many there are. We just counted and said there are 7 numbers total. So we added it together and divided by how many numbers there were. That is how you always find the mean, is add it together, count up how many there are, and divide by that number. Does that help clarify? Hopefully that did help. Yes. Okay. Yes. I can wait one more minute so you can finish writing it down. Okay. So I had prepared stuff on fractions. There's also the patterns section, patterns and functions, which can be pretty difficult. I think we could do both. We still have about a half hour. I was planning an hour for this whole thing. So let's talk about adding and subtracting fractions and multiplying and dividing fractions, and then hopefully we can make it to patterns and functions. So adding and subtracting fractions, when you're adding fractions, you need something called a common denominator. And our first problem I wrote out has one. If you have a common denominator, it's pretty straightforward. You add the tops, leave the denominator the same. And it's great to do a visual representation of this. So if you cut kind of like pie pieces, and we said, well, one of these pie pieces out of the 5 plus 2 of these pie pieces out of the 5 then total we have 3 out of 5 pie pieces. The reason we keep the 5 on the bottom and don't add 5 plus 5 is because it's just telling us the size of our pie pieces. We've cut this into sizes where there are 5 equal pie pieces. So the 1/5 plus 2/5 is the 3/5. 3 out of 5 pie pieces. The problem comes when we're not cut into the same number of pie pieces. We can add things together that were the same size. Here we have 3 out of 8. Here we have 1 out of 4. So 3 out of 8 would be much smaller pie pieces versus 1 out of 4. So sometimes you can take one of them and just only change that fraction so that you get a common denominator. It's good to look at the lower number, the 4, and see if there's any way you can multiply it to make an 8. So what could we multiply this 4 by so that we get 8? And then we'll have that same common denominator. So what do we multiply 4 by so that we would end up with an 8? And it does need to be a whole number. We can't like use a decimal. But you could multiply 4 times a 2 to get an 8. When you're working with fractions, though, what you do to the bottom, you do to the top. So this becomes 2 out of 8. And now that you have a common denominator, you can combine the numerators. You leave 8 in the denominator, and 3 minus 2 is 1. And that's your final answer. So once you've made it into that common denominator, you can combine those numerators, get your final answer. And picture-wise, if you wanted to think of it as a picture, when we multiplied it by 2, we cut each of these pie pieces into half their size. So now we had 2 out of 8 pie pieces instead of 1 out of 4. So when you're working with one where it's easy to multiply to the bigger number, that's all you need to do. One like this, there is no number that you can multiply 3 by to get to an 8. There's a decimal, but we want just whole numbers only. So if both denominators need to be changed, then it's easiest to use the denominator of the other fraction. So 5 over 8, we would use the 3. And 1 over 3, we would use the 8. Use the denominator of the other fraction. That way, you're doing 3 times 8 on both of them, and you'll get the same denominator. So same idea though, what we did to the bottom, we multiplied the 8 by 3 so that we get the same denominator of 24. You have to multiply the top by 3. 3 times 5 is 15. The second fraction, 3 times 8 is 24, and 1 times 8 is 8. Once you have the common denominator, we keep the denominator the same. That's just telling us that this was cut into 24 pieces, and we add the numerator. 15 plus 8 is 23. And that's your final answer. You do want to check to see if it will reduce. Let me show you a fraction that will reduce, because this one does not. If you had 6 over 8, that would reduce because both of them can divide by 2. And they will always keep the fractions in simplest form. So you always want to check at the end and think to yourself, could this reduce? Is there anything that divides into both of these numbers? And if there's not, that's just the final answer. So any questions on the adding or subtracting fractions? This is part of the adding rational numbers and subtracting rational numbers section. They also talk about adding decimals and stuff, but usually fractions are the hardest part, so that's what I wanted to focus on. I'm going to give just a little bit of time, make sure everyone is caught up before moving forward. So next is multiplying and dividing. So multiplying fractions is pretty straightforward. It's not as good to do a picture for this one. That's actually harder to think about. It's easier to just know how to, and all you do is multiply numerator times numerator, denominator times denominator. We don't have to worry about common denominators. We don't have to make any changes. We can just go straight to multiplying. So 3 multiplied by -1 is -3, and 5 multiplied by 6 is 30. So we just multiplied each set individually. You can write the negative on the top of the fraction. Sometimes they would write it in front. That is the exact same thing, it's just 2 different ways to write it. So those don't really matter if they place it in front of the 3 directly or in front of the whole fraction. But we do always want to check to see if this reduces. So what divides into both 3 and also into 30? What one number divides into both 3 and into 30? Close, okay? That's a good guess. Oftentimes, 2 is going to be your answer. Like 90% of the time, it's going to be 2. The problem is, if we try to divide 3 by 2, that gives you the decimal 1.5. And we never want a decimal mixed in with a fraction. So both of these can divide by 3. If your answer is not 2 to reduce, the other part of the time, it's probably 3. There's definitely different numbers that will work, but 90% of the time, 2 or 3 is going to be the way this divides. So 3 divided by 3 gives you 1, and 30 divided by 3 is 10. And if you ever get down to a 1, you don't need to keep asking if it will reduce. 1 cannot reduce any further. Sometimes you'll pick 2 or 3 and then maybe you'll have to do it again. Sometimes you only have to do it once. So dividing fractions, when you're dividing fractions, it's kind of a weird setup. Again, a picture doesn't really help. You just kind of have to know the process. So you keep the first fraction the same. Then we change a few things. The divide sign is going to change to multiply. And the second fraction is going to flip. We call this the reciprocal when we flip a fraction upside down. So once you've done that, now it's just back to a multiply problem. Now you multiply top to top, bottom to bottom. We do have a -1 multiplied by a -8, so we have to think about a negative multiplying by a negative, which changes it to positive, which we don't really write in front. You just have to know now it's positive. And 1 times 8 is 8. Then we do the bottom, 2 times 5, which is 10. And so we do check to see if we reduce, and usually either 2 or 3. This time it's a 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. So I didn't prepare a whole lot for patterns and functions, but I still want to talk about it anyway. I was going to see if we had any extra time. Unless anyone has a specific topic they do want me to cover, feel free to write it in the chat and we can do that instead. So patterns and functions, well, let me give just a little bit more time, make sure everyone's done writing anything down before going to a new page. Okay, so I'm going to go ahead and move forward. Again, if you do want a copy of these notes, I'll save them and send them to you if you missed anything. Patterns and functions. The goal of a function is to find a situation and actually come up with a math equation for that situation so that you could predict what's going to happen later on. One of the common ones used is in the past for cell phone plans. Most of the time you paid by minute. So for a cell phone plan, maybe you paid $20 just to own the phone plus 5 cents a minute. Which isn't really the case anymore, but it's the one I always think of. So you can actually create a math equation for this and use it to predict, well, what's going to happen if I speak for 30 minutes. So $20 plus means use an actual plus sign. 5 cents a minute, that means to multiply by however many minutes you talk. And we're looking for the total cost, so I'm going to say C for cost. So once you have an equation, or they call this a function, once you have a function that describes this situation, you could predict. You could say, well, what if I want to know how much is it going to cost me if I speak for 30 minutes? Well, all we do is substitute in. This is one of the reasons we learn order of operations in the first place. You substitute in for m the 30, and we know, according to order of operations, you multiply before you add. So 0.05 times 30, I'm going to do this in my handheld calculator so you can still look at this screen. 0.05 times 30 is 1.5. So 20 plus 1.5. Now we do the addition. That's 21.5, or in context of the problem, $21.50. So talking half an hour wouldn't really cost you a whole lot. You could figure out for, maybe you'll talk 1,000 minutes. You could figure out for any number of minutes. So you can do this from a situation. Often they like to give you a set of data and you go back to an equation. This was gave you a situation and you came up with an equation. I'm going to go ahead and move forward to the next page. Like I said, I'm just trying to make sure, give enough time for everyone to write stuff down. Okay. So oftentimes, instead of giving you an actual situation where there's kind of some context to it, they'll just give you a table. So the x values are your inputs. That would have been our minutes. They often call that the domain as well. Whatever you're able to plug into the equation is domain or input. Kind of has a lot of different names. So what they're going to give you is a whole bunch of input-output pairs. They're giving you, if you plugged in 1, you would come out with 5. If you plugged in 2, you'd come out with 8. If you plugged in 3, you'd come out with 11. But it's a little harder to think of it and work through it when there's no context. Like the cell phone one, you knew, oh, this is how much I was charged originally, this is how much per minute. This is just a random set of numbers. But it could be related to an actual situation. Just often when we practice, we don't write out situations every single time. So with the cell phone situation, we had a starting amount, and we had that amount per minute. And I'm going to call that the rate of change. So if we can find both of those values, we can create our own equation. We always do the output first. Our output on the last one was the cost. We wanted to know eventually what was the cost. Output on this one is the y values. It's almost always, if they do x and y, input is x, output is y. So our output is going to equal that starting amount, which we have to find still, plus the rate of change, I'm just going to write change, times the output. So in this case, times x. We know the x, and our goal is to figure out what number do I put here, what number do I put here. So when it's just a whole bunch of data like this, it's easiest to find the rate of change first. Even though starting amount comes the first part of our problem, rate of change is easiest. And that's the difference between each set of numbers. How much do we go up by to get from a 5 to an 8? And I should specify this is the rate or the change of the y values of the outputs. So how much does it take to go from a 5 up to an 8? How much more would we need to get from 5 to 8? So to get from a 5 to an 8, we would have to add 3. And that's the same every time. And we'll mostly be starting with basic ones, so the domain should always be going up by 1. Later on, we'll learn what to do in different sections, what to do if these don't go up by 1. So we change by 3 every time. That's the rate of change. That's how much we're changing every single time we go to a new set of input-output pairs. So now we know this is a 3. Why 3? Because 5 plus 3 is 8. And 8 plus 3 would give you 11. And 11 plus 3 is 14. Fantastic question. It's what we're adding every time to get to the next number. If you're ever not sure, if it's too large of a gap or the numbers are just weird, you could also subtract. You could say, I'm going to do 8 minus 5. It has to be the ones directly next to each other. And that gives you the 3. So then you know 5 plus 3 is 8. So that's our rate of change. Thank you again for that question. Now to get to the starting amount would be what we are if we're back at 0. If we go backwards. So to go backwards, instead of adding the 3, we want to subtract that rate of change. We want to go 5 backwards to what we would have started with at 0. So 5 minus the 3 gives us a 2. And that will be our starting amount because that's what we are at 0. Many of the problems are about like wages, you know, how much money you're making per hour. So oftentimes the starting amount is 0 because if you don't work any hours, you don't make any money. But it's always best to do that kind of backwards process so that you can see exactly what that starting number should be. So this final answer is 2 plus 3x. This is the function that describes this table. So I think that's all for today, but I'm still happy to answer any questions if you have any additional questions about any of the topics we've talked about today. Or just about how the course works or when everything is due. Happy to answer any questions you have. I would be very happy to send you a copy of this lesson. I'll do that as soon as it takes a minute to kind of process the stuff, so I'll send it in like 5 or 10 minutes once it's all processed. We are probably planning on doing another one of these. We're going to try and do more of these group lessons to try and reach as many people as possible. I think one of my colleagues, Rachel, she's helping me with this. She might send you some information and ask some questions on what you thought or if time should be different. For now, probably plan on the same time next week, but I'll send another chat out to try and reach everyone and say, are you interested in doing this? And you can always send me chat messages or emails if you have any other questions before the next group lesson. Well, thank you guys very much for joining us. It was perfect. I'm glad it helped out and glad we can get you through this. Sorry again about my dogs at the beginning. They're not usually that loud. I'm glad you understood. Okay, well, have a great day, everyone. And you can just close out of the Hangout or hit the end button to end the call.